I have the recording from the first half, so this is just going to be a second recording to add on to that. But what you do is you get the current position, and then let's say you want to go, let's say you want to go like 5 inches. What you do is you see this counts per inch. That's the amount of ticks you go every inch. And the way you calculate that is if the wheel has, hold on. So you see right here, it says the wheel has 537 ticks. So if you have that many ticks, and you know that 537 equals your wheel's circumference, because once you've gone through all 360 degrees, that means you've gone the wheel's full circumference. Does that make sense?
Yeah.
Yeah. So this is in ticks, and this is in inches. So to get 1 inch, you divide 537 by 2 pi r. Yeah, that's what you do. And that's your counts per inch. So you just like do some measurements with the wheel with like a tape measure or something like that. And then your counts per inch would be 500. So that's what I'm going to use. And right here, we're going to do plus that times 5. Let's see, we want to go like 5 inches. Does that make sense? How you like go 5 inches from your current position?
Yeah.
Yeah, so that's pretty much it. And you do the same thing for the left front, left back, left front, right front.
You do them all for 5 too, right?
Huh?
You do them all for 5 too, like for the other motors too?
Yeah, I can do it for all of them.
Okay.
But you would have to get like, if you were to do this for the left front, you need to do left front motor, and then you need to change that to left front.
Yeah, okay. That makes sense.
And but that's actually not that's not the full thing. That's just half of it. So I'm gonna write the rest of these. Oh, whoops. Okay, so now that I wrote that, there's one more step you have to do. You need a while loop, and you need to check. So what this does is, once you set the target position, that doesn't really do anything because you never set a speed. So if you don't set a speed, how does the computer know what to run the robot at? And that's what you have to do inside this while loop. So all this setting the target position does is it tells the right back motor that it should be doing something because it's not at that target position yet. But what it has to do, it doesn't really know unless you actually check those. And what you want to do is check the left front and the right back. I mean the right front. And then check the right back. You want to check all 4. I don't know what would happen if you only check the 2 front. I've never tried that, but you can try it, I guess, and see how that goes. But what do you think you would do inside of this while loop? Any ideas?
Maybe. Wait, so the while loop is for setting the speed because there's like set the speed inside of it?
Yeah, it's what you want to do while the stuff is busy.
This is while is busy.
Yeah.
Wait. Oh.
Mark also had one question. Why don't you use or statements. These are or statements.
Is wild.
I never tried or statements. You could try or statements. You know, you have a lot of freedom here. But I think and the reason why you use and is because you don't want like one motor might be off of it, and you don't want that one motor to keep moving when the other three have stopped. That is what I think.
Okay.
Any ideas for this while loop though? That was a small tangent. I can just write it if you want me to write it.
I don't really know what to do there.
Okay. So what you do here is this code will keep running while each of the motors are busy. So you just want to set the power here.
Oh, like the speed, right?
Yep. Yeah, exactly. Yep. Excellent, Mark. This is class participation. So also, again, you don't have to like write this all 4 times because it's really repetitive. If you go into the drivetrain, there's something to set it all in one line. Just, I think it's called set power. Yeah, it sets the power for all 4. And you set the power for all of those. And then once they're not busy, you also have to set the power to 0 again. Because if you don't set it to 0, the robot does not know to stop. So that's it. That's how you make the robot move forward for 5 inches.
That's so cool.
Yeah. And what I do in this drivetrain, it's pretty much the same thing, just with a few more additions. This is the code that I showed you before. And what you do is, again, set the target positions. And if we go to that, it's right here. We do the same thing. We take in a few inches, and we get the current position, and we set the target position. And, yeah. And then you also activate the run to position mode, where you set to run to position, and then you set a left and right speed. And the reason why you do that is because before I was talking about that, you call this drift compensation. That's what you call it, where the robot, you want it to go straight forward, but it starts moving like that. So this is called drift compensation, when you make the robot turn back this way. And the way you do that is you increase the speed on the right side and you decrease the speed on the left side. If you like try to act it out with your like hands or something, or I don't know, if you make something move faster on the right side and slower on the left side, it's kind of like rotating it. You can kind of see it like rotates like that in a circle. So that's how you get it to move back to the forward position. So that's why you need a left speed and a right speed, because you need both of them to be able to like control the stuff, control the way the robot turns. And you set the power to all the speeds, and while those motors are busy, you find an error. This error is the thing where like how much the robot's off from the desired angle, which if you want to go straight forward would be 0 degrees. And then you just use that error and either add it or subtract it, so the robot either turns left or right to go back to the forward position. And then once you're done, you just set the power again after you do all those calculations. You reset the encoder once you're done, and you set the power to 0.
Okay.
Okay. I think that is all I had for today.
Okay. Are we gonna? Is there gonna be another one next week? No.
Yeah, I can do one more. I think we still have to talk about strafing,
Okay.
where the robot moves left and right, but we're almost done.
Okay. Thank you.
Yep. No problem.
Thank you so much.
Yep.
Bye.
Okay, goodbye. I'm gonna be ending this meeting now, so.